Okay, so let's continue talking about the second part of the unit. You might remember as a brief review that yesterday we talked about the, what was it? Oh, about
Terrors.
Irina.
Okay.
You might remember Irina's speech about, well, Irina is an ecological advisor and he's talking to a group of engineers. You might remember that. He talked about and compare the ideas of the pre-use, in-use, and post-use of the product phases. Mhm. And you might remember that the main point that Irina makes in this, it's that it's important to consider the total environmental impact of a product. That means to
Yep.
including the produce of it, that means the pre-use, the use of the product, that means the in use, and the recycling of the product, that means the post use. Okay, an example was the energy saving light bulb. You might remember that. Mm-hmm.
Yep. I remember.
Okay.
Well, she talk about effects to our environment, environment and
Mm-hmm.
environment, and he talked. She talked about light bulb, like product,
Uh-huh.
and explain maybe um, process, maybe process about two environments. That's okay. Okay,
Mm-hmm.
it's interesting.
Yes. Okay, perfect. So, of course, we're going to continue just to finish with Irina. In
Mhm.
this case, I'm going to play another audio. Okay. In this part, Irina asked the engineers to
Uh-huh.
do a simplified environmental audit. The task in here is to compare the steel versus the aluminum car bodywork from ecological perspective. So you're going to
Oh.
listen to Sophia
Mhm.
and Pete, that are the two engineers, and they're going to discuss about what is better, to have a steel or an aluminum car bodywork, like the skeleton of the car in steel
Yes.
or in aluminum. What's better from an ecological perspective, of course.
Mhm.
So you can make notes of their ideas, okay? Because this is an audio of about 3 minutes, 2 minutes and a half.
Yes, it's very fast.
So it's long. So you should to consider this, and of course, make notes if were necessary. So before I play the audio, I want to know your point of view. In an ecological perspective, which one
Mhm.
do you think it's better, to have a steel or an aluminum car bodywork?
I think it can be. I mean, I saw that like advantage and disadvantage. No,
Uh-huh.
because advantage aluminum is good for some effects in systems or materials where aluminum is good, and
Okay.
steel is different, but it's no, we don't have uh, cost very high.
Okay.
I think for me is cheap. It's it's cheaper than aluminum
Okay.
sometimes.
Mm-hmm.
Well, I think is that. Mm, I
That's a
think is that.
point of view.
Mhm.
Mm-hmm. Okay,
It depends.
perfect.
It depends.
Okay. So Let me play the audio. Listen carefully and try to make notes, okay?
Okay.
Remember, it's Sophia and Pete are going to discuss about steel and aluminum car bodywork. And in this case, the coach is gonna be Irina. So listen to their point of view.
Okay.
I'm gonna play the audio.
2.2.
Okay, so steel bodywork versus aluminium bodywork.
What about pre-use then?
Well, I think it takes a lot of energy to produce aluminium compared with steel, because aluminium's made by electrolysis.
Yeah, so steel's better, presumably.
I think so, yeah. But hang on a minute. With aluminium, it depends how much is derived from ore and how much is recovered from recycled material. As far as I know, recycling aluminium takes less energy, so I'm not really sure.
Presumably it'll be mixed, won't it? For a given batch there'll be so much new material and so much recycled material.
Probably, yeah. Okay, so that needs to be researched then.
Is car bodywork galvanised when it's made from steel?
Oh, good question. I'm not sure.
If it is, if it has to be coated with zinc, then that would take extra material and extra energy, so that's an important consideration.
True. Okay, so that's another question to note.
Then there's the energy consumed when they're transporting bulk metal to the car plant.
Presumably aluminium takes less energy to transport, being lighter.
I'd say so, yeah.
Okay, what about manufacturing?
Well, aluminium would be lighter to handle, wouldn't it? It probably takes less energy to cut as well.
Yeah. Not sure whether it takes less energy to weld compared with steel.
Good question. Another thing to check out.
What about in use then? I assume aluminium's better because it's lighter, so you consume less fuel.
Yeah, and it should last longer as well.
Is that an environmental consideration, though?
Well, yeah, because if things last longer, they need to be manufactured less often, so you use less energy.
True. But then, is the lifespan of a car determined by the life of its bodywork?
Good point.
It's usually determined by the chassis or the engine, isn't it?
Is it?
Another one to be researched.
Okay, what about post-use then?
Okay. So you were able to listen during this audio the comparison and different points and notes that you should know when compare steel or aluminum for a car bodywork.
Yes. Yes. Well, I think she compared different process where aluminum can be in use, pre-use and use and post-use. But in this case, she talked about advantage using the aluminum or steel. For me, it's interesting the environmental consideration where she explained the life of materials, like bodywork. She explained that usually she determined the chassis like age of vehicle, but she talked maybe she's Pete, right? Pete talked about different process. I think it was aluminum production, and coating, process of coating and welding.
Exactly.
Talk about weight, maybe weight, frequency of manufacturing. thing.
Okay, that was for the in-use part.
Our lifespan, right? It's
Lifespan, yes, a lifespan, that means the
right.
frequency. That's the
Yes,
in-use
yes.
also. She mentioned, well, they were discussing about the pre-use, about,
Yes.
she mentioned the aluminum production. That means about the extraction from the ore and recycling it.
Okay.
Also mentioned the galvanizing to create the aluminum, the
Oh yes,
coating steel.
galvanizing. Yes.
Transporting and handling bulk material. I mean, if it's easier to do the cuts and the welding, of course. And that
Exactly.
was in the previous part. And of course, in the in-use now, they talk about the weight, that means the impact on fuel consumption, and the lifespan, that's the frequency of manufacturing, of course.
Yes, nowadays it's important that because always we always talk about that full consumption. So I think there's still well, this is very has a weight different to the aluminum, but it's important what kind of material is using in the production of the cars. No? I mean, maybe we have compact cars with aluminum, but the speed or the speed is better in some cars. No.
Yes, of course.
It's a good idea in this case how they explain that advantage in difference of materials, no? Of the materials, yes.
Okay, great, thank you. So I just want to point a little bit more. Let me make another zooming here in this part. Where you have application and materials on the bottom part of the page.
Okay.
And I want you to focus in one part of the two topics. We have electrical wires in vehicles and external walls in houses. Which of these two topics would you like more to focus in this part?
Talking about materials or?
Yes, we're gonna make like a pro and the pre-use, the in-use, and the post-use. Okay, we're gonna do the same as the listening, but of course, using this topic now, not about steel or aluminum car body work, but now these electrical wires in vehicles or external walls in houses.
Well,
I don't know which topic likes the best.
Yes. Well, electric wires in vehicles, maybe. About that, as far I know, the electric wires in vehicle is a new topic or the new form of the vehicles or where the cars travel to short distance. I think so is good for an environment, and maybe we should take or might take an important consideration like electricity, because it is different to the fuel or petroleum. I don't know. And I think it should be researched, or it needs to be researched. I think it's a good option. It's a good option nowadays. No.
And talking about the electrical wires in vehicles, you have two different materials that you can use to work with electrical wires. I mean
Yes.
copper and aluminum.
Yes.
Okay.
Exactly. Yes.
So the idea here is Vincing from an ecological perspective.
Yeah.
Which one do you think would be better? Talking about in the pre-use, the in-use, and the post-use between copper and aluminum. I mean, we're going to compare one more time, but now copper versus aluminum for electrical wires. Which one do you think or consider it's the best option? You have below the sandbox with some phrases that you can use in order to express your point of view.
Copper and aluminum.
Mhm.
Well, when I remember system, electrical system,
Uh-huh.
I saw, I always see different materials with copper and aluminum. But if you consider the environment, maybe I can think in aluminum, right? But I don't know if that material is important or mean or no. The importance is different to the copper. I mean, I have to analyze the system or the electrical system where I can use copper and I can use aluminum. So for me, it's important consider the function in any system, electrical system. No.
Uh-huh. Okay. Talking about the pre-use, let's divide this in three sections. The pre-use,
Yeah, pre-use, in-use, and
in-use.
post-use.
So talking about pre-use, as far as I know, it takes more energy to produce aluminum than to produce copper.
Yes, it's more energy with aluminum.
So if it's derived from ore, but however, it takes less energy to transport aluminum because it's lighter. So it's pros and cons. I mean, in production, aluminum, it's even more energy than copper. But in transportation, then aluminum, it's better than copper.
Yes, and Sophia said about the electrolysis
Electrolysis,
about the aluminum. So it's very expensive. Electrolysis is an effect different with the copper, no?
Yes, like that. And
Talking
now,
about
what
this
about the
copper.
in-use? The in-use now, what about it?
Use.
Between the copper and aluminum.
And if I...
What do you think about that?
Well, in use, I think the aluminum is better. I think it's better because with the aluminum material, talking about cars, the cars get more speed, less fuel consumption. I mean, and it takes basically I think less cost. No, less cost. I think it's that in that effect for in use. No.
Okay. So you should be sure that with aluminum, it's better because it's lighter.
Okay.
So,
Yes.
so the vehicle would consume less fuel because if it's lighter, then it moves faster. That means that you spend less fuel.
Faster.
So that's like a different point of view, being since an ecological perspective.
Exactly.
And what about the post-use? That means when we need to recycle or we want to recycle the car.
In this case, both aluminum and copper can be recycled.
Yes, of course.
Yes, yes, because it's interesting for
Yes,
this
I
class
agree
of
with you.
materials.
Both aluminum and copper can be recycled, yes.
Yes.
But which one do you think would be better? I mean, talking about ecological perspective, which one do you spend less energy to recycle?
Uh, well, most maybe I can. Well, I think the aluminum
Mm-hmm.
takes takes less
Energy
energy, takes less energy for
Mhm.
transport
To
and
transport and to handle, yes.
to handle. Yes, yes, exactly.
Great. So that's the way that you need to think about when you want to talk about application of something new and the materials you need. Okay. So
Uh-huh,
whenever you need or you're going to have a new product or something, talking about production, mass
uh-huh.
production,
More production. Okay.
taking in mind the ecological perspective, you start from these 2 points, thinking in the application of what you want to do, the product or the device, and the materials needed for that device. Now, think about the pre-use. How
Mhm,
much does it cost in energy, in transportation, in
mhm,
handling,
mhm,
to create that device? Now, meanwhile, I'm using that device, which one is my advantage? And
mhm,
once my device pass out, that means expires,
uh-huh,
then what about recycling? How much do I
uh-huh.
need to spend this energy to recycle this device?
Mhm.
Mhm. So
Exactly.
we can sign these 3 points as the main idea of the materials. Mhm. When
Okay.
talking about recycling materials.
Yes, it's very common, this class of materials. Maybe
Mhm.
we can use in the home and several parts. The useful of these materials is important and
Exactly.
very interesting.
Mhm. Just like a fast review, I'm gonna mention just a little bit about external walls in houses.
Ah, okay.
And they mentioned 2 materials, bricks and
Uh-huh.
softwood.
Bricks and software. Ah,
Mhm.
okay.
So
Yes.
for pre-use, it takes a lot
Mhm.
of energy to produce bricks because they have to be fired in a kiln,
Uh-huh.
and they are also heavy to transport.
Uh-huh.
Meanwhile, the softwood is lighter to transport, and it's probably take less energy to saw it and to handle it because it's
Mm.
wood. You just cut it, compared with making bricks. Now,
Mhm.
uh, in the end use, wood is better insulator than brick, which is an advantage. That means that as the house should take less energy to heat,
Uh-huh.
in theory, softwood could last as long as the bricks if it's
Uh-huh.
properly maintained. But in
Mm.
practice, that will often not be the case. That means people do not know the maintenance of the wood so that they last as
Yes,
if they were
exactly.
bricks.
Exactly. Yes.
And finally, in the post-use, it's possible to recover both bricks and softwood to
Uh-huh.
reuse. I mean, but neither is very easy to recycle. I mean, it's not easy to recycle wood and it's not easy to recycle bricks,
Exactly.
but they're possible to both be recycled. Mhm.
Okay.
I mean, that was like the point of view in this one.
Mhm.
So knowing this one, I think we can jump now into the categorizing materials in the next page. I don't know if you're now in that part.
Let me see. Okay. In this part is number 4, right?
Yes.
The question is,
So,
what do you know about braking system? And players
mhm.
discuss the following questions. And like number 1 is
So,
generally speaking, what the
mhm,
brakes do and how do they work. And the
exactly.
second, mhm. What
But
kind of material are used in brake pads and brake discs in different vehicles? Okay, interesting.
mhm. So talking about categorizing materials, before we begin at all, I have a question. What do you know, or what do you mean by
Hmm.
categorizing materials?
Uh, I think classification or
Okay,
level of materials. Or
to label materials in
yes,
categories or types.
okay, okay,
Okay,
yes.
great. And for example,
Mm-hmm.
let's talk about two specific materials to
Mm-hmm.
have an example. If we talk
Mm-hmm.
about metals, which one would be two examples of metals?
To steel, uh,
Steel,
yes, steel,
and let's say
maybe
copper.
copper,
Yes,
and,
that's great. So you got the idea, okay? Now, during
mhm.
this part of the section, you will
Okay,
find the following vocabulary useful. Let me write
uh-huh.
it in here for you.
Okay.
So during this part, you will find this word like something that you need, such as compound, exotic, known for material, okay, not like fruits and stuff like that. We also got the word ferrous,
Ferrous,
non-ferrous,
no, ferrous, okay.
mhm, the ceramic, of course, an alloy, metallic, non-metallic, and the polymer that it's one of the most recently.
Mhm.
Mhm.
Yes.
So these words are known as the categories of the materials, talking about engineering. If they're a polymer, if the material is not metallic or metallic, if it's an alloy, is it ceramic, is it non-ferrous, ferrous, exotic, or if it's a compound.
Mhm.
Mhm.
Yes, there are different materials.
Yes, like
Yeah.
that. So, knowing this before, talking about the categories of the materials, let's talk about this. In the first part, the question is, what do we know about braking systems? I mean, when you brake, you're driving and there's a red light, you brake, you slow down. So, generally speaking, what do brakes do and how do they work? That's the question.
Yes. Well, talking about brakes, when I talk uh, about brakes, it's a system in the vehicles um, for to well, it's a system in the vehicles to stop the vehicle or live in movement.
Uh-huh.
If I apply a pedal or pressure pedal, the car has a system where uh, press a disc or a drum directly and take take the control of movement. Um, this kind of breaks maybe can include systems like I don't know, electric or or controlled
Mhm.
by pressure or oil pressure.
Okay.
Uh, I think it's that, no, more or less.
Yes. Actually, we could say that brakes, generally speaking,
Yes.
brakes are designed to slow down vehicles, or not
Okay.
only vehicles, but also moving parts, like in
Exactly.
machine.
Yes. Yes.
Uh,
Yes.
and they often work through friction. That means
Hmm.
you apply pressure
Yes.
to the pads, which of course are pressed against the sides of a disc inside a drum, or maybe directly to the
Uh-huh.
wheel rim.
Exactly.
And of
Exactly.
course, there are some alternative, as you mentioned. We can have something that is known as a brake of electromagnetic force.
Exactly.
We also have like aerodynamic braking system when we talk about aircrafts or parachutes, and reverse thrusters that it goes for engines, for jet engines. And if we talk about the second one, it's what kind of material are used in brake pads and brake discs in different vehicles? So let's talk about a car, and why not an airplane, train maybe? So what are the different materials that we can use to have a brake and a brake disc?
Ferrous or not ferrous,
Uh-huh.
materials like that.
Which one would you apply for ferrous metals? In which kind of brake for which vehicle?
Maybe in brake disc, maybe in brake disc, because that kind of material is different. I can that part is iron and
Uh-huh.
and and maybe like polymer or ceramic, maybe polymer or ceramic.
Yes, the ceramic could also be used.
Exactly. So I think is that kind of material. So I can use in that part
Uh-huh.
and break this. Break this. It's
Yes.
important break this.
So for example, if we talk about the cars,
Huh?
we can, as material, I think they use a compound of different
Exactly.
materials for the
Yes.
brake system.
Uh-huh.
If we talk about trains, then we talk about big and a lot of weight vehicle. So we need
Yes.
something known as the ferrous metals. That means
Yes.
something that is
Oh
heavier.
yes. Yes. That's right.
And
That's right.
if we talk about something little like as a bicycle, then the bicycles use the rubber. The bicycle use a rubber brake. I don't know if you have seen the bicycles that there's like two rubbers that press into the wheel.
Exactly.
And if we talk about performance cars or like the Formula One and stuff like that, we talk about ceramic, of course.
Yep.
That's the main idea of the different materials and different vehicles.
Yes. 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 It's
Great.
normal that that affects different vehicles. No?
Yes. Great. So talking about this one now, look at letter A. Could you please read that?
Letter A. Read the article on braking system. In the title of the article, what do the colors green and red refer to?
Okay, so we're going to see something about the titles in here. We're going to read this article about braking systems.
Yes.
But look, the title, it's green brakes, and then you have a red hot topic in motor racing. So the title, it's in these colors because of something. But we need to read this article to know why the colors of this.
Yes.
So let me upload this. I think here it's better, but of course you have the book so you can read. So could you please help me reading since the title until the part that it says in here ceramics? You're gonna read since the title into this part of ceramics, and the other half I'm gonna read it.
Okay.
So please, could you start?
Ceramics. Ceramics.
Yes, but you're going to read. I mean, the first part. Read it, please.
Okay.
Until ceramics.
As motor racing goes green, Formula One is aiming to lead automotive research in pending high-tech efficiency gains. One of the keys of this ecological drive is regenerative braking, also known as kinetic energy recovery, which recovers energy generated during deceleration and store it as a source of power of subsequent acceleration. Regenerative brakes limit the energy loss inherent in traditional braking system. In most vehicles, conventional brakes comprise pads previously made from asbestos-based composites, but now consisting of compounds of exotic non-hazardous materials, and this made of ferrous metal. The resulting friction generates heat, which is waste in performance cars. This phenomenon is taken to extremes, and due to the high temperatures generated, brake discs are often made out of ceramics. Okay.
So then it says, the carbon disc and pads are used on Formula One cars generate so much heat that they glow red hot. High temperatures are, in fact, necessary for the effective operation of carbon brakes, but there is still plenty of potential for recovering the kinetic energy, rather than merely dissipating it into from heat. The potential energy for recovering energy also extends to the heat generated by engines and exhaust systems. This area has also been discussed as a possible area for the future exploitation in motor racing. Heat recovery might offer the added benefit of reducing heat soak, that means the thermal absorption by the chassis, as delicate alloy parts and sensitive non-metallic materials such as polymers are susceptible to heat damage.
Okay.
So now that we read this one, what do you think? What do you think colors green and red refers to? I mean, what it says, green brakes are red hot topic in motor racing. Why green brakes? It's in green brakes.
Yes.
Which one do you think it's like the idea of this?
Well, I think is that material that not produce damage to the environment, or
exactly.
Yes.
So we can mention it's green brakes because it's green refers to ecological issues.
Okay.
You can write it down, ecological issues. That's why it's green. And why does it mentions red? The color red. It says a red hot topic in motor racing. What do they mean if they say red hot topic?
Well, I read a hot topic. I think it is like a material, a bad material to the environment. No, I think it is well. Here is talking about the temperature, high temperature in different systems or operation with materials like I don't know, carbon or I think materials with wear or materials worn in that effect with the brakes function with the vehicle. I think is that, no? I think.
Okay. We can mention that a red hot, in this case, red hot means very hot. So if we say that a red hot topic, that means a very hot topic, we might say that it's because it's current important. I mean, like something new, a red hot topic, something that it's new and something that it's important.
Okay. Okay.
That
Okay.
might have that part.
Uh-huh.
Great. So now that we also read this article, we have 4 questions to answer. I think you can write down the answer in case it's not enough space. I hope you can underline it on the article. So could you please read the question, Paul?
Number 1, why do most braking system waste energy?
So what would be the answer? Why do most braking systems waste energy? What according to this article, why?
Yes, yes. Check. Most energy. I don't remember that this part. I saw that. Which recovers energy generated during this deceleration, or is,
So I mean, braking systems waste energy. Yes, it has to do with that about acceleration. I think the answer that you're looking for is because they use friction. So
okay.
they waste energy because they use friction. And what happened when they use friction? They waste energy as heat. I mean, the energy that they apply to brake causes friction. And
Yeah.
when something causes friction, I mean, a clear example is if you rub your hands together due to friction, and you feel something hot in your hands.
Yes, high temperature.
So
I can get high temperature in that part.
yes, so of course that heat, it's energy. That in this case, as the basic laws of physics says, energy does not create or destroys, it transforms. So
Okay.
my energy, I'm transforming it into heat in my hands when I rub them together. So it's the same in here. In my braking system, I waste energy because when I brake, I cause friction, and the friction causes heat.
Yeah, yeah. The friction causes heat. Exactly.
That's that would be like the best answer for number 1. Yes.
Okay.
Then
So,
number 2, could you please read that one?
yep. The second question is, what are regenerative braking system, and how do they save energy? Well, he talked about regeneration.
So what do they
And
mean with that? What are regenerative braking systems? And why do they save energy? I mean, what's the difference?
yes. Yeah, well, when we talk about the regenerative braking systems, is talking about ecological form where the brakes system recovers energy generated, no? But in this case, talking about save, and save, maybe maybe we have a source of power, a source of power for that acceleration, or where I can use more more the subsequent acceleration, or
Uh-huh.
I think it's that. I think.
Okay. Well, we can talk about regenerative braking systems that they save energy, actually because they recover the heat. You might remember that in a typical or in a quotidian braking system, we said that we waste energy as heat. So in this new regenerative braking system, the heat that we waste, now we absorb it, we recover it. That means that you use the power in the car. So that heat, it's transformed into power, so the car could accelerate even more.
Okay.
So you could write for number to that. I mean,
Yes.
they recover heat and use it to power.
Exactly. Well, okay, that's okay. Then the number 3.
So could you please read it?
Okay, is what characteristics are required of materials used for the brakes on racing cars? Okay. Well, in that part, I think that cars generate high friction or
Yes.
high levels friction.
Uh-huh.
And sure, that cars resist that temperatures of high frictions.
Exactly.
Because that produce high temperature or heat or so much heat, and that cars has has a characteristics like generate several levels, like
Yes.
they can use high
I mean,
speeds.
that was a great answer, and actually it was the answer I was looking for. So when we talk about characteristics, that means that these materials need to have the ability to generate high levels of friction, and of course to resist the effects of friction and consequent heat.
Exactly, yes.
So that's the answer, actually. Yes, perfect. So write it down.
Okay. What is meant by heat shock, and why it is a problem in racing cars? Okay.
So what do they mean with heat shock?
Can you help me that heat shock? Because I don't shock. I don't remember that word.
Oh, you have
Shock.
never listened of it.
Yes.
So, well, soak, in this case, if we're talking about Spanish, it's like sumergir.
Okay. Yes, I know. Yes, I understand. Okay. Well,
So
in
what
this
about
case,
heat soak?
I think I'm thinking in temperature. No, when the temperature is high, that class of energy is absorbed for different parts. I mean, thinking about plastic parts or chassis or bodyworks. Maybe it can produce also heat and that part. And I think is that kind of energy is absorbed by that parts, no, chassis, and bodyworks, and I don't know, in that kind of detail, that kind of details is are sensible parts, no? Are sensible parts for the car or for the vehicle. I think it's that. No, I think.
Okay. Yes. So what we mean by heat soak, I mean, it's the heat from the engine that is being absorbed by the chassis.
Uh-huh.
So, you know, it's
Thermal
typically that,
absorption, yes.
when you drive the
Uh-huh.
car for a long time and you stop and you put your hand into the chassis of the motor or the engine, it feels hot.
Yeah.
And
Yeah.
sometimes I think you have seen that sometimes the cars spill white smoke from the car, like.
Uh-huh.
So that's a part. So in this case, that's the heat soak. It's the heat from the engine that is absorbed as thermal energy by the chassis.
Exactly. Okay.
And what is the problem? I mean, why is this a problem in racing cars? Well, as you said, because they can damage the sensitive parts like electronic components or plastic parts.
Talking about non-metallic materials, right?
Exactly. I mean, because if they're metallic materials, then they just got hit and that's enough. But if we talk about electronic wires and plastic parts, then they might not tolerate or absorb that quantity of heat. And that causes that they burn. And of course, the cars spills out.
It's a problem. Okay.
Yeah. I mean, that's the main idea in here about this one. So, talking about these words, you have on the article some bold words, okay? I just want you to repeat with me these bold words. It's these compounds.
Compounds.
Exotic.
Exotic.
Ferrous. Ceramics. Alloy. Non-metallic. Polymers.
Yes.
Okay, so with these words, we're gonna use them to match the materials to the description. So do you have an exercise letter C? The 7 words: compound, exotic, ferrous, ceramics, alloy, non-metallic, and polymers. So now match them. Look at it. Compounds. What are compounds? They said in here. Oh, it's a combination of material.
The combination materials because compounds. Combination of materials.
Then what about exotic? What is exotic?
Exotic. Let me check. Rare or complex? No.
Rare or complex? Yes. Great. The next one, please.
The next is ferrous.
Ferrous.
Maybe is minerals. No, materials that are not metal. Just no.
Ferrous?
No. Sorry. It's small. It's minerals transformed by heat.
And yes. No, in this case, no. Ferrous, we talk about metals. Because it's ferrous.
Mixture of metals.
It's iron and steel. Yes, that's named as ferrous materials, iron and steel.
Okay.
Now, what we call ceramics?
Ceramics. Well, ceramics is minerals transformed by it. Yes, that's great. See, no, it's minerals. Letter F. Yes.
Which one do you say? For F. Yes, ceramics. It's minerals transformed by heat.
Okay. And alloy.
Alloy. What about alloy?
Alloys is it's mixture of metals.
It's a mixture, a combination of metals. Yes.
Okay. Non-metallic is letter A. Materials that are non-metal. And polymers, combination of materials.
So the last one, polymers.
Sorry. Plastic materials.
Plastic materials. Yes. Exactly. So I hope you match them.
Okay.
Yes.
Yeah.
Okay.
It's okay.
So, before we continue to this part, I want to make an extra resource sheet about this part of the materials. So let me change my screen into PowerPoint. in this part.
Okay.
It says Unit 2 Materials Technology, a resource sheet to see. This is an extra activity for you to understand the different material category. So could you please, I don't know if you're able to read the instructions, and if you have a notebook, I don't know if it's able for you to copy the chart.
Okay.
Mm-hmm.
Okay. Do you want that I copy that table?
Yes. Or
Okay.
what I can do is we can work in this, and I take the screenshot and I send
Okay.
it to the group, so that you in another opportunity had to write it down into your notebook.
Okay. Okay.
Mm-hmm. Let me take the screenshot of this one, and I'll send it to this part.
Yeah. I take one screenshot too.
Mm-hmm. So do you want me to send it by WhatsApp, this screenshot, or you save it?
I don't know. What do you want? If you.
I mean, we're gonna work. The idea is that you got it so that you can write it down in your notebook, if in case you do not have time right now.
Okay. Okay, no problem. If you can, you send me
Mm-hmm.
by WhatsApp, right?
Okay, let me just connect my WhatsApp in here. Well, it's changing. So let's see. Could you please read the instructions?
Complete the table using the materials in the box. You will need to use each materials more than once. Add any other example you think of.
Exactly. Let me send the screen. Here it is.
Okay.
There, I sent it on the group.
That's right.
So that you got it in there. Okay, so yes, we're gonna use this table. You have a sandbox up down. So for example, we have aluminum, bronze, copper, glass, iron, nylon, steel, and synthetic rubber. And of course, you have the different material category. If it's metal, if it's an alloy, a non-metal, a ferrous metal, a non-ferrous metal, a polymer, or a ceramic.
Okay. Well, in this part, I'm thinking in metals like bronze, steel.
Okay, bronze, yes. Bronze, steel,
Copper,
copper,
and iron. Right?
iron. Yes, that's great.
Yes.
Now, what about alloys? From the materials that we have up in the sandbox, which ones are known for alloys? Remember, what is an alloy? The combination of metals.
Okay. Combination of metals is bronze. No. Steel.
Steel, yes. Another example could be the stainless steel.
Stainless steel, yes.
What about the non-metals?
For the non-metals, it can be glass, rubber or synthetic rubber.
Synthetic rubber, yes.
Yes, and well,
and
nylon. Maybe nylon, yes.
Nylon. Great.
For the ferrous metals.
Metals.
Is iron and steel.
Iron and steel.
Yes. in this case, for non-ferrous metals, can be copper,
Copper, okay.
bronze, and aluminum.
And aluminum.
Aluminum.
It's the same. Aluminum if you're kind of American, and aluminum if it's kind of British.
For polymers, can be synthetic rubber.
Okay, synthetic rubber, yes.
And nylon.
And which one?
Ceramics. Well, I don't know. I think nylon.
Oh, in
nylon.
polymers, yes, nylon.
And ceramics.
Oh, that's just one.
Yes, glass.
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 Yes, just glass into a ceramic part.
Yes.
Excellent. Great, great, great. When you finish writing, you tell me.
Yes. One second. Thank you.
Ready. Okay, let me move in here. Okay. So let me just close this window. Let me erase this. Close this. Let me save them. And there it is. Oh, I stop in here. Now, I'm going to give you a kind of a homework for you to get the idea. Okay, I want you to search, well, to look out for some other meanings. Okay, just for us to have even more vocabulary.
Okay.
So I'm gonna. I don't know if you have your notebook in there.
Yep.
Yep. Okay. I don't know if you could in another page so that you don't mix the activities. If you could write extension activity.
Extension activity.
Extension activity. 2 points. Vocabulary. More vocabulary. All the words that I'm gonna give you are from the article, okay? So
just this article, right? Green
yes,
Breaks.
this article, the one of Green Breaks, yes. I just want you to look for the meaning of automotive.
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 Okay.
I don't know if you want to write out. Well, I'm gonna highlight it in here, okay? I'm gonna highlight it so that you know, in case you do not remember how to write it down. I want you to look for the meaning of automotive.
Excellent.
Deceleration.
Deceleration, okay.
Asbestos.
Asbestos.
Composite.
Okay, composite.
Non-hazardous. Non-hazardous.
What is it?
Actually, I'm looking for that word because I do not find it in here. But I'm looking at it. Let me just hold a second. Oh, I don't look at it, but I think it's in here. Well, you write it like non-space hazardous. Oh, here it is. It's at the bottom.
Hazardous.
Non-hazardous. I already pointed in there.
Okay.
And exhaust.
Exhaust.
Exhaust. Exhaust with H. It's in here. Oh my God, where is it? Oh my God, I'm bad looking at these words. Oh, here it is. Exhaust systems. Exhaust. There are 6 words.
Okay.
So that would be a great activity for you to got even more vocabulary. So I just want you to look out the meaning of these
Okay.
terms, so that you got a little bit more detail.
No problem.
You can, I mean, you can only write the meaning if you want to.
Okay.
Right? Let me erase these things. Okay. That's how we're supposed to finish.